This is the gram-positive rods bacteriology tutorial presented by the SchrDbb. We reference Lippincott Illustrated Review of Microbiology by Cynthia Cornilesson, Bruce Fisher, and Richard Harvey. So here we are going to visualize gram-positive rods. So we start with the classification of gram-positive rods. So according to free-living bacteria, you can say that free-living bacteria divide into gram-positive and gram-negative. So for gram-positive, we can have cocci and we have rods. We have already seen tutorials on cocci, so now we are on rods. Is it clear? So on rods, we have the rods. Gram-positive rods can be consisting of the Coryn bacterium. Example of Coryn bacterium, we have Coryn bacterium diphtheria. The gram-positive rod consists of bacillus. Example of bacillus, we have Bacillus anthracis, Bacillus cereus. Gram-positive rods can also consist of the Listeria. Example of Listeria, we have Listeria monocytogenes. Gram-positive rods consist of the Propionibacterium. Example of Propionibacterium is Propionibacterium acne. Another example of a gram-positive rod is a Lactobacillus. And the last example is Erysipelotrix. Example is Erysipelotrix rhosiopathy. Now, so that's the classification. So after the classification, the next thing to visualize are the action of the diphtheria toxins. So we start with the Coryn bacterium diphtheria producing the diphtheria toxins. So we need to know that the diphtheria toxin is going to have a membrane-bound receptor that is going to recognize and bind a portion of the toxins. Is it clear? So the diphtheria toxin is going to bind on a receptor on the membrane. Is it clear? So when it binds on the receptor of the membrane, the cell is going to intake that receptor. Now, the toxin is going to enter the cell by the receptor-mediated endocytosis and is going to dissociate into two fragments. We are going to have a fragment A and fragment B. The fragment A is the active form inside the cell. So active fragment of the toxin is fragment A, while fragment B is just the one that has been used to bind to the receptor. Is it clear? Now, the fragment A is going to be translocated to the cytosol. It means it's going to be translocated to the cytoplasm, where it's going to catalyze the transfer of adenosine diphosphate ribose from NAD plus to EF2. Is it clear? So it's going to cause the transfer of it's going to be translocating to cause a catalysis of transfer of adenosine diphosphate. Is it clear? So it's going to result to this receptor. So the ADPR elongation factor complex is going to be inactivated and the peptide synthesis is going to stop. Is it clear? So you are going to all this is going to result to a stoppage of the peptide synthesis. Now, NAD is just meaning nicotine adenine dinucleotide, and EF2 just means eukaryotype polypeptide chain. It means that it's that active factor of the diphtheria toxin is just going to inhibit the formation of the peptide in the eukaryotic cells. Is it clear? When there is inhibition of the formation of peptide in eukaryotic cells, it means that the metabolism is going to be inhibited, and when metabolism is going to be inhibited, the cell is going to eventually die. So this is an example of diphtheria. Diphtheria with marked swelling of the lymph nodes. So you see there are cervical lymph node that can be seen here, and if you open the mouth of this child, you're going to visualize cellular membranes inside at the level of the tonsils and the level of the pharynx. So that's going to show diphtheria. So to make a diagnosis, you can swap the cellular membrane and you're going to see Coryn bacterium diphtheria. Coryn bacterium diphtheria are rod shaped, they are gram-positive, and they are existing in chain, as you can see here. They are rod shaped, gram-positive, existing chain, Coryn bacterium diphtheria. So let's visualize a small summary on Coryn bacterium species. So Coryn bacterium diphtheria is gram-positive, as you can see here, and they are rod shaped. The Coryn bacterium diphtheria on the phalloid blood medium is going to appear as such. So when you place Coryn bacterium diphtheria on the phalloid blood medium, it's going to appear with this pattern. So this is a pattern of growth of Coryn bacterium diphtheria on the phalloid blood medium. Now, what are the characteristics of Coryn bacterium diphtheria? They are small slender pleomorphic rods, small, slender, pleomorphic. Pleomorphic just means that there are multiple shaped rods, but the typical shape is rectangular, that is rod. So pleomorphic rod that form characteristic clumps. Is it clear? So it's going to form characteristic clumps that are going to look like Chinese characters. They form characteristic clumps that looks like Chinese character or a picket fence. Is it clear? So just clumps like Staphylococcus aureus, but in this case they are going to produce clumps which are rod shaped. Is it clear? To produce the different Chinese characters. So they are non-motile and also unencapsulated, unlike in the case of Staphylococcus pneumoniae, which are encapsulated. Most species are facultative anaerobes. Is it clear? Most species of the Corynebacterium diphtheria are facultative anaerobes. The next, a culture aerobically on selective medium, such as the medium where their culture is the Tinsdale agar, is also going to contain fluoride. So containing fluoride, is it clear? So it is mostly grown on the Tinsdale agar containing fluoride. Now, the next thing of diphtheria, of Corynebacterium diphtheria, are the treatment protocol. The first line in case of Corynebacterium diphtheria is erythromycin, and erythromycin is an example of a macrolide, and the second line is penicillin G. Now, Corynebacterium diphtheria, you can see inside the mouth, inside the pharynx of this child, you are going to visualize pseudomembranes. So these are pseudomembranes, whitish structures, plaques here, which can be visualized. So infection of the throat, you can see gross soft swelling of the and congestion of the whole pharynx with exudates, gray exudates called pseudomembranes at the level of this part here, producing plaques. Now, so that is the different characteristic of that part. Now, the next thing is the Bacillus species. So Bacillus species, it consists of the different, so you need to know that Bacillus has been used for bioterrorism in the year 19th during the World Wars. Is it clear? So the Bacillus species was transmitted via documents, and then they were transported from one country to another to cause bioterrorism. Is it clear? That Bacillus, before when antibiotics were not existing, people were really, the Bacillus has been a real threat to life of humanity. Is it clear? So in bioterrorism, there was inhalation and contamination via dust. Is it clear? It's going to produce the Wool-Salters disease. Is it clear? The next, it can also be due to contact. It can be due to spread via airborne disease, via droplet infections, or it can also be due to contact with contaminated animals and products like hides, like wools or hairs. Is it clear? So even spores that contaminate or hide in herbivores and cattle so may enter. So the cattle and all that still just serve as a reservoir for the Bacillus. Is it clear? The cattle were reservoirs of Bacillus, and humans can contact it via the contact of the skin, or they can contact it via inhalation still from it, and then they are also heat resistant. Is it clear? On the soil, you can be present at the level of the soil, and they are heat resistant, and that soil is going to contaminate the cattle, and also the soil can contaminate the human. So generally, you need to know that it can be air infection, or it can be due to a contact. Is it clear? So generally, that's a mode of spread of Bacillus anthracis. Clinical significance of anthracis is that there are different forms of anthracis. There is cutaneous anthrax. So cutaneous anthrax is one form. The next one is pulmonary anthrax. Those are the two main forms of Bacillus anthracis. Now, the cutaneous anthrax is when you get it via contact. So 95% of cases of the human anthrax is cutaneous anthrax. Now, the other form of anthrax is pulmonary anthrax, which is called the Wool-Salters disease, which is gotten due to the spores infecting the air. Is it clear? Now, this is Bacillus species. So Bacillus species is still a gram-positive. So as you can see on this diagram, you see a gram-positive Bacillus anthracis culture. Is it clear? Showing typical bacilli with highly refractory unstained spores. So you can visualize spores inside here which are going to be unstained. So this is how you visualize Bacillus anthracis. So it's gram-positive rods, as you can see here, and you can see unstained spores inside the anthracis, Bacillus anthracis. Now this is the usual non-hemolytic culture on the blood agar. So on the blood agar it is non-hemolytic. Is it clear? So the next is going to be blunt end. So these are the characteristics of Bacillus species. One is that it is going to be blunt-ended bacilli that occur singly or in pair. So they occur singly or in pair, or frequently in long chains. So they can also occur in chains, unlike the Corynebacterium diphtheria that was occurring in clumps to produce Chinese leather. This one occur in long chains. The next is that it forms endospores, is it clear, which are oval and centrally located. So endospores are produced here, which are oval and centrally located. It produces non-motile. They are non-motile with capsules that are anti-phagocytic, prevent phagocytosis. They are facultative. They are facultative or strictly aerobic microorganisms, meaning that they, in absence of oxygen, they may not even live. They are facultative of strictly aerobic organism. And culture on blood agar. Blood agar is one of the agar which is best for the culture of all the microorganisms which are produced. So this is an example of a cutaneous anthracis, and this is an example of a chest X-ray with a patient who have a pulmonary anthrax showing widening of the mediastinum. You see that the mediastinum here is widened. So is it clear on the chest X-ray of pulmonary anthracis, and this is a case of a cutaneous anthrax. So now, what are the drugs which are used for a different anthrax? So for cutaneous anthrax, the primary drugs used is the ciprofloxacin. Is it clear? For pulmonary anthrax, which is also called a Wool-Salter disease, the multi-drug therapy is going to be recommended. So the first multi-drug therapy that is recommended in pulmonary anthrax is ciprofloxacin plus rifampicin plus clindamycin. Or we can use a multiple drug therapy of ciprofloxacin, rifampicin, and vancomycin. So this is a drug to use in case of Bacillus anthracis. Now the next disease is going to be Listeria, and the most species there is Listeria monocytogenes. So this is the life cycle of Listeria. So Listeria is phagocytized by macrophage and is going to be incorporated into the phagolysosomes. Is it clear? So when the macrophages are going to incorporate it, the second step is that you have bacterial product, that is the listerolysine O, is going to lyse the phagolysosome, allowing to escape the Listeria. So the Listeria is going to escape and is going to enter into the cytoplasm of the macrophages. Now Listeria multiply and assembles an actin filament. So it's going to have assembled actin filament tail, as you can see here, because it's only actin filament at the level of the mammalian cells. So when the macrophage is going to engulf the Listeria, and the Listeria has broken up the lysosomes that were the phagosomes produced by the macrophages by the listerolysine O toxins, they are going to incorporate themselves the actin filaments of the macrophages. That's why the Listeria multiply and assemble the actin filament to produce a tail that is going to push the bacterium to the surface of the macrophages. Now when it now is going to be pushed to the surface of the macrophages, now it goes to step 4. A pseudopod is going to extension form and facilitating the transfer. So we have actin filament is now going to transfer now to another macrophage. Is facilitating transfer of Listeria into another phagocyte, and that's how it's going to be transferred to different phagocytes, and it's going to continue its life cycle. So in this case, so after entering here, it's going to divide again in this cell and then incorporate again other actin filament tails, which is going to help it to incorporate again another macrophage, and that's how it's going to expand in the host cells. Now, this is a generalities of the Listeria species. The Listeria species are the characteristics that they are slender, they are short rods, and sometimes occurring as diplococci or in short chains. That's the first characteristic. They can occur as rods, which are single, diplococci, or short chains. The second one is they are intracellular parasites, just as you have seen in the inside the life cycle. They are catalase positive, just like the Staphylococcus species. They are distinctive tumbling motility in liquid medium. Is it clear? So there is distinctive tumbling motility in liquid medium, and it grows facultatively on various enriched media. So this is an example of Listeria monocytogenes cerebrospinal fluid, which are gram-positive rods. Is it clear? And then this is Listeria monocytogene on the blood agar. This is how the pattern of Listeria monocytogene is going to grow on blood agar. Now you need to know that the disease caused by Listeria monocytogene is called listeriosis. Is it clear? And listeriosis, now to treat it, the first line is ampicillin. Is it clear? To treat Listeria, and then trimethoprim and sulfamethoxazole is the second line. If ampicillin have not worked, then you use trimethoprim, sulfamethoxazole. Now we have other non-spore forming gram-positive rods can also be seen. Is it clear? So other non-spore forming gram-positive rods we have, and we have studied about the erysipelotrix rhiziopathy, which is a filamentous gram-positive rod that can cause a disease in animals and rarely cause a skin infection called erysipeloid in people who are commonly handling animals. Is it clear? Erysipelas and erysipeloids are two different diseases. Erysipeloid is mostly occurring in butchers, veterinarians, and fishermen. Is it clear? Other disorder, we have Propionibacterium acne, which is in a genus of anaerobic microorganisms or microaerophilic rods. They have diphtheroid-like morphology, that's a Chinese-like appearance. Is it clear? And they are going to cause acne. So the next one is they are going to cause acne. The next one is lactobacillus, is also among the other non-sporing gram-positive rods, and they are forming commensals of the human mucosal part of the vagina, and they are going to produce lactic acid that are going to maintain a low pH to prevent the overgrowth inside the vaginal mucosa. So from here we can say thanks for your kind attention, and don't forget to like and subscribe for our channel Science Video Makers. Thanks very much.